In this section, we want to look at various parts of a data, parameter versus statistics, qualitative versus quantitative, discrete versus continuous, and various levels of measurements. And now we are going to look at this section, starting the idea behind some definitions. And remember, the idea behind statistics is very simple. Generally speaking, we don't have access to a population, so we use a sample to make a conclusion about the population.
Parameter, a numerical measurement describing some characteristic of a population. Statistic, a numerical measurement describing some characteristic of a sample based on a sample.
CHIS, a recent California health interview survey included 2,799 adolescent residents of California. Periodic table, the average mean atomic weight of all elements in the periodic table is 134.355 unified atomic mass units.
So what do you think? Which one is which? The first one?
Parameter.
We had only, it doesn't matter, it was fairly large, 2,799, but nevertheless, it was a sample. Therefore, it's a statistic. Going back to the first one, it is referring to a sample of size 2,799. When you want to distinguish between the two, pay attention to whether you're dealing with the whole or a portion of it. How about this one?
The percentage of all students on campus who have a job is 85%. A sample of 200 students is obtained, and from this sample, we find that 83% have a job.
You really have to pay attention to this. The word all may not be there explicitly, okay? It may be there implicitly. You have to read the question very carefully. Later on, when we do statistical questions that we have to go through some calculations, I'll show you how we do it by starting with the given symbolically. Quantitative versus qualitative. We want to discuss that.
Numerical data consists of numbers representing counts or measurements.
And so obviously, examples such as weights or ages. Categorical.
Categorical or qualitative or attribute data consists of names or labels, not numbers that represent counts or measurements.
Examples like genders, and this is the one that you want to pay attention to. There are two ways to approach this. One easy way, just anything involving numbers versus something that doesn't involve numbers. However, that involve numbers, but the numbers really refer to a category. They do not represent quantitative. Examples would be zip codes or your student ID. Although they are numerical, but they represent qualitative. So that's important to pay attention to. So what happens is that data is cut into two types, qualitative and quantitative. Then when we have the quantitative, we may have them countable or discrete. Examples of that, the number of chairs or the number of cars. In other words, it is countable and it is a whole number. Now, it's important to understand when it comes to quantitative, we may have it a continuous. Continuous takes place over an interval.
Discrete data result when the data values are quantitative and the number of values is finite or countable. And there's an example, the number of tosses of a coin before getting tails. Continuous or numerical data result from infinitely many possible quantitative values where the collection of values is not countable. Takes place in an interval. The example, the lengths of distances from 0 centimeters to 12 centimeters.
In short, discrete means countable and continuous takes place in an interval. So we have qualitative and quantitative. Quantitative is either discrete or continuous. Now, one thing that happens, you can't say I have 2.1 cars, but you can say every household in the United States has, let's say, 2.1 cars on the average. Okay, that we can say it, but you can't say I have 2.1 cars. All right, we want to see if you're dealing with a discrete or continuous variable.
Among the subjects surveyed as part of the California Health Interview Survey, several subjects are randomly selected and their heights are recorded.
Okay, so what are we dealing with here?
Continuous.
Very good.
I have a question on that front.
Sure, sure.
Because realistically speaking, we never record heights very accurately. We never.
I know. You're right. You're absolutely right. Go ahead.
Okay.
We are assuming that we do. See, the thing is, it is important to know it is continuous. So, for example, let's say somebody is 6'1". Is it really 6'1" or is it 6 and then 1.578? We don't even that, but at the very least, 6'1" itself, 6 feet 1 inches. At
The
least
heights
is.
themselves would be continuous, but the recorded heights surely wouldn't be, right?
What do you mean by recorded heights? We are supposed to. I mean, we are supposed to write them as they are given to us. Okay, if you mean by recorded heights referring to the number of heights that was, recorded, no, it's discrete. But this is referring to the heights itself.
Oh, I see. Okay. Thank you.
Does that make sense?
Yes.
My pleasure.
Absolutely.
Excellent question. So what is the next one?
House attendance. The clerk of the U.S. House of Representatives records the number of representatives present at each session.
And that is?
Discrete.
Discrete.
Very good. The number of representatives. You have so many, and that's countable and discrete. This page, there's a lot to be read. There are different levels of measurement, and sometimes they are not easy to recognize. I want you to know that some of them are very straightforward. Some of them may not be. As we go through the examples for the exam, you don't have to worry about it. The questions will be very straightforward.
Level of measurement characterized by data that consists of names, labels, or categories only, and the data cannot be arranged in some order, such as low to high. For an example, survey responses of yes, no, and undecided.
Level of measurement involves data that can be arranged in some order, but differences obtained by subtraction between data values either cannot be determined or are meaningless. Example, course grades A, B, C, D, or F. Level of measurement involves data that can be arranged in order, and the differences between data values can be found and are meaningful. However, there is no natural zero starting point at which none of the quantity is present. A value of 0 does not mean the absence of the quantity. Arithmetic operations such as addition and subtraction can be performed on values of the variable. Example, years 1000, 2000, 1776, and 1492.
And the last one, ratio level of measurement.
Level of measurement data can be arranged in order, differences can be found and are meaningful, and there is a natural zero starting point, where zeros indicate that none of the quantity is present. Differences in ratios are both meaningful. Arithmetic operations such as multiplication and division can be performed on the values of the variable. Example, class times of 50 minutes and 100 minutes.
So some of them are straightforward, some of them, depending on the question, could be confusing, but in short, nominal really is the qualitative that we have discussed. Ordinal gives us some sort of a ranking. Interval differences are there, but there is no natural zero. Now, what does natural zero mean? It may not mean much to much of people. A ratio differences and a natural 0 point is there. But what's important for ratio to understand, 0 means non-existence, okay? That's the idea behind that. That might be helpful. So let's look at an example, see if we can do this. And again, we have a fairly short definition of those here. So if we are looking at variables such as hair color, I think everybody can see that it's clearly, there is nothing to it. It's qualitative, so it's nominal. Zip code. Zip code is the same thing, class. I want to make sure everybody is comfortable with that concept. Zip code, student ID, things of that nature that really give us a category, if you will. A zip code, in essence, you can think of instead of giving the name of your neighborhood, you give the zip code or city or town or your name, you know what I mean. So it's not, it doesn't really have a numerical value in that sense. Okay, letter grade was already discussed. Okay. ACT scores. Okay, it's interval. By the way, when we look at this. You don't have to worry about this table. What really matters is this, if you will. For this one, this is what matters. For this one, this is what matters, okay? That means it covers the other ones. Okay, so I wouldn't worry about that. The height has all of the above, okay? Again, it doesn't matter. It's a ratio, okay? Height of 0 means non-existence, okay? Okay, age is the same thing. Age of 0, that means non-existent. A temperature was discussed. Temperature is one of those that is interval, and again, this is what matters. So you really want to look at this last column, if you will, okay? You can ignore the previous ones. And again, as far as what we are dealing with, we make sure to look at cases that are very straightforward.
Sorry,
Yes.
I had a question about, can you kind of go into why temperature is interval?
Well, when you look at the temperature, if it's, let's say, 30 degrees versus 15 degrees, it doesn't mean that it's twice as hot, as an example, okay? That's one idea behind it. You can't assume it's twice as hot. It's just warmer by 15 degrees, okay? Or when it's 0 degree, it doesn't mean lack of heat, okay? That's how they define that. But as I mentioned, in some cases, it may be confusing. But one of those that has been used on a normal basis is temperature. So temperature, based on what statisticians believe is an interval level of measurement. I hope that answers the question.
Yeah, thank you.
My pleasure. We went over something similar to that.
In a survey of 1,000 adults, subjects were asked how often they washed their hands after using a public restroom. 74% of the respondents said always.
The first part, I think we did identify the sample and the population. And now part B, is the value of 74% a statistic?
Is it a parameter?
We're looking at a survey of 1,000. So this is a sample. Everybody knows that, right?
Yeah.
It's a statistic.
Therefore,
right?
this is the statistic. Definitely it's a statistic. It's a sample. So in other words, if we were to write the given, we would write n lowercase is 1,000. P is the proportion, is 0.74. This is coming up, but I thought it's worth mentioning it here. So n is 1,000 low and p is 0.74. Because if we are dealing with the population, class, I'm going to write it here. If we are dealing with the population, then notation calls for capital N represents the size of the population, and P represents the proportion for the population. Excellent. So with that being the case, let's go to the next one, the level of measurement. Remember what's happening. 74% of the respondents said always. This is what?
Nominal?
Nominal. No.
No. I'm sorry.
It's
Ratio.
the highest one. It's the ratio. Very good. That's right. And the numbers, discrete or continuous?
Discrete.
Statistic, ratio, discrete.
Why would it be ratio?
Okay, can anybody tell us why it's ratio? See, the value is 74%, right? Remember what happens. We are looking at this level of measurement as far as this 74% is concerned. What about if it's 10%, 20%, 30%, or 0%? 0% means lack of it. And is 74% 2 times 37%, as an example?
Yes.
So that's one way to check it. So it's ratio. Does that make sense?
Yes, it does. Thank you.
My pleasure. Let's look at this question. We have 4 situations, and we want to figure out the level of measurements that we are dealing with. So the first one, different voters.
Nominal?
Nominal. Does that make sense?
Yeah.
The next one is about time. We've already discussed that.
Ratio.
Perfect. Then we are looking at rating a movie. Good, bad, I don't know, 4 stars, 2 stars,
Interval?
more than enough. Okay, it's just small, medium, large. So that's the same. And we've already discussed the temperature. It's an interval. Okay, let's look at the last question.
People who report the last 4 digits of their social security numbers and the average of those digits are calculated.
What's wrong with that?
Wouldn't the SSN be like the student ID, so it's actually a nominal value? So
Exactly. It doesn't have any numerical value. You're absolutely correct. So the digits are not really counts, okay? So they represent a person, okay, a category, qualitative data, and therefore their average makes no sense. And so we're going to look at sampling methods. In this section, there are other things involved. The main thing that we are concerned with is the sampling method. We may quickly cover other things. We don't have to worry about it too much. So there are different methods: random, systematic, stratified, cluster, and convenient sampling. We want to distinguish between observational study and experiment.